All right, team, here we go. So, remember, in logarithms, you have 5 rules, and I told you that you only needed to know the first 3. Out of the first 3, I'd say most students will know the first 2. So, law number 1, law number 2. This is what you would have copied in our last session. Law 1, law 2. If you have them multiplying, 2 things that are multiplying, so notice where the brackets are, you're logging the multiplication of 2 items, then you can split it up into 2 separate individual logs, right? It's the opposite of indices. Indices is if you have 2 separate terms and you multiply them together, you can combine them as 1. Notice log is the reverse. Log is when you have them multiplying together as combined as 1, you can separate them into 2, right? So law number 1, if you times, you add them. If you divide, then you subtract them. Very similar to indices. Then you get into law number 3. This is the most common one to do for your exams next year. Okay, so if they throw in a log next year, in your exams, I promise you, it's going to start somewhere with number 3 first. Where's the example? I'll just go back to our year 12 exam. So here we go. What's an example of this if we just scroll back up? These are all the solutions. Here we go. Oh, welcome team. So, can you see, where is one that we can see straight off the bat? Let's do, I know it's all a bit confusing here. Here we go. This is a good example. So if you have a look at this example here, I'm going to highlight it on the screen so those who are watching this video will understand what I'm saying. See here, this is what? M equals Maths Exam 1, 2009, so it's quite a while ago, more than a decade away. Those years when they did logarithms, notice here, you would naturally say this is a law number 2. Yeah? Law number 2 says if you can subtract them separately, you can combine them as one rule where it's division. Yeah? We said if you divide them, you can separate them into separate ones where you take away. So most students, when they do this, back then, they would say, oh yeah, I'm going to use rule number 2, and what I'm going to do is this is what I'm going to write. This is what most students will write. They'll say, okay, law number 2 says that I can write it as log base E of x over x plus 3. And they'll continue. Okay, so they'll continue from there, and already just from that step, that is wrong. Okay, because what they wanted you to see is that in your rules, I'm going to go back to your rule number 2 just so you can see the difference here. Rule number 2 never said, so I'm just going back. Rule number 2 here never said that there can be a number at the front of log. True? So have a look at the two rules. There's log a of n minus log a of n. If I go back to that question again, let's have a look at that question once it loads. That has log e of x, take away log e of x plus 3, true, but there's a 2 there. That 2 is a problem. You can't use law number 2 when there is a number right in front of those logs, when it's multiplied to it. Okay, and that's the misunderstanding here. You can't use this rule where you're saying, oh yeah, I'll just since they're take away, I'll ignore the 2 at the front and I'll just combine these 2. You can't do that. Okay, so why is rule number 3 important? Because rule number 3, and this is what I want you to copy down, so rule number 3 says, if you have the number at the front, so notice here in rule number 3, you've got the p, this p value, you can actually bring it up as part of the powers. There's a proof to it, but for now I'm teaching you how to do it. Okay, so here, you've got the number p, you can bring it as m to the power of p. That's what rule number 3 says. So if I go back to this VCAR problem, this one, what you were meant to do at the very start, okay, because that very first step you'll be marked wrong straight away. That doesn't work, okay? Your answers will be wrong. What you were meant to do is instead of saying, oh yeah, I'm just going to combine these 2, you can't do that based on the rule. You actually had to use rule number 3 and convert this so that it is now log base e of x squared. See, I'm using rule number 3 where it said p can be reversed to being m to the power of p. That's what I'm doing there. So now you've got log e of x squared minus log e of x plus 3. That's okay to use rule number 2 now. There's nothing wrong. Rule number 2 says if you got log e with the same base minus another log e with the same base, you can then say with subtraction, you'll be doing x squared divided by x plus 3. And that's okay. All right, but you couldn't have done that from the beginning and just write 2 log e of x over x plus 3. That's the most common misconception. So I've been there since forever. From my time to your time is because students still do the same thing. Because you're still going through logarithmic rules and you're saying, oh yeah, 2 separate ones, when you minus, let's just divide them. And that's the first thing you do. You do the things that you know. You do the things that are easy. But there's a step for every one of them. Okay, so rule number 3, very common, 100%. If you had to do a logarithmic problem, try to find where you can put rule number 3 in. Often is the case. Okay, so having that in mind, let's try, and that's why you don't need to know rule number 4, because rule number 4 essentially is following the same idea. This number here is -1. If you use number 3, you're just bringing -1 up, and that's why it's m-1. That's why I'm saying you don't need to know rule number 4. If you understood what logarithms meant, you don't need to know rule number 5. So really, the only 3 rules that you needed to know was 1, 2, and 3. But out of the 3, you should already know the first 2. It's just number 3 that most students tend to forget. So once you see that, it's quite a straightforward exercise, isn't it? There's only 3 rules that you play around with, and that's what Year 12 exam's got to be. That's why it's so short. I've already printed out a bunch of exam questions for you, and that's what you're going to be doing next year, learning how to solve. Yep.
Is Rule 3 just an extension of Rule 1?
Rule 3,
Because
it came from Rule 1, but
P is 2 is just the same as M and N being the same.
mn, this is m times n,
Yeah.
and this one is m to the power of p, which means it's m times m x amount, depending on the number of p.
In the previous one, P was 2, right? And so
Yep.
if P is 2, then you can work it out with.
Oh, yeah, you can think of it that way too. Yeah, essentially, yes, you're right. So if it was 2, let's go with that. Log a of m squared, you're saying that this is the same thing as writing log a of m times m, which then becomes log a. Using rule number 1, you can split them up into log a of m plus log a of m, which is why if you're adding 2 of the same logs, you would say, I've got 2 groups of log a of m. Correct. And that then becomes the rule. True? Very good. So maybe if you understand it to that level, you only need to understand law number 1 and law number 2. And then that's it. True? All right, so now you've got, actually maybe I should keep that there. I don't know if it confuses you guys, but you only need 3 rules for this exercise. Okay? Let's do some examples just to get your head around. So let's have a look at example 21 here. Here we go. So first instincts, like I said, most students will look at this and go, yep, they all have a base 10. All base 10. So your natural instincts to say, if you're adding, you can combine them, which is true, but what's the problem? You can't just combine those 2 and say log 10 of 3 times 16. Why?
I was going to say something else. Divide the third term by the first term first.
Divide the third term by the first term first.
As in like, becomes 2 log 3 divided by 6 over 5.
2 log 3 divided by 6 over 5.
Is the first term and the second term
The 2.
Oh, as in like this one and this one?
Yeah.
Oh, yeah. I see what you're trying to say. Yeah, you could also do it that way too. Yeah, and that would be another way. So this is what I mean. That you can use and do whichever method you think works for you. Okay, so here yeah, that probably would be easier than doing, say, bring the 2 up and then bring the 2 up. Okay, so that's using rule number 3, if you were to do that, but you can combine, since these 2 are technically the same, there's a 2 in front of them, you can say the technique is taking 2 as a common factor. This now becomes 2 taking times log base 10 of 3 minus log base 10 of 6 on 5. Double brackets there, okay, because they both have a common factor of 2. That's a 2, and that's a 2 there. And so now you can say, using rule number 2, since they're subtracting each other, you can then divide them, and that's what Dylan was saying there. You can just divide the first term and the last term there. That becomes log 10 of 3 over 6 on 5. I'll probably take away the bracket so it doesn't confuse you. Okay, so that's one way of doing it, and then obviously depending, and don't forget we still have that other third term that was plus log 10 of 16. Notice that in your textbooks they don't use the brackets unless otherwise. I always use the brackets. Okay, so I encourage you to use the brackets. So the reason why is because I've seen some of my top students in year 12 when they're solving it, and I'll give you an example. Sometimes when you're in the rush in a SAC or an assessment like that, the question becomes a bit unclear. Is this log e of x plus 3, or is it log e of x at 3? Because they're two different things. Okay, one is shifting the graph to the left by 3, and one is shifting the graph up by 3. Okay, and one of my good students, they were doing everything correct, and in that heat of the moment, from this step, they then chose that it is this question. But actually, it was this question, and that changed the student's answer. Okay, and I told them from the beginning, I said, fix your layout, and they wouldn't listen because they're really good, they always pass, and they do really well, and then when it counts, they don't do it right. So fix your layouts, okay? Habits, when I tell you to do it, practice it, because those are the things that in the heat of the moment you may forget, okay? So make sure to put the brackets in part of your working solutions here. So in all my calculations, notice I always use brackets to avoid making that mistake. So here we go. We're doing log base 10 of 16, and then depending on your algebra, remember I said it's all about algebra from here. 3 divided by 6/5. What does that equal to? Some of us may find that a bit tricky. So for those who do find it tricky, it's the same thing as saying 3 divided by 6/5. If you write it that way, it makes it much easier to do. Okay, so that's the same thing as saying 3 times the reciprocal. We can say that becomes half. So really it's 5 halves. Okay, if that helps you with your fractions. Okay, so here we go. We've got now, the next line is 2 times log base 10 of 5 halves plus log base 10 of 16. What are you going to do now? Okay, so sometimes in exam, when students get here, they again do the same mistake. What do? They will use rule number 1 and combine those two. Okay, but you can't do that. You can't do that. You have to use rule number 3 first. And Max?
Can you make it 4 squared and put 2 out?
4 squared.
16.
Oh, yeah, you can do that. Yeah, that's another way. So very good. So another way to play around with it, yes, you can do log 10 of 4 squared, which is 16, and then using rule number 3, you can pull the 2 out, and that way you have both the 2's there as well. So that's another way of looking at it as well. So when it comes to simplifying, there are always multiple ways, but the more you explore, the better for you. So that means that you're getting used to using rule 1, 2, and 3. Okay, so here, if I kept it with that sort of concept, log 2 times log 10 of 5 over 2, plus, in this case now this becomes 2 log 4. Then what we have now is, since they both have the 2's there, you can combine them now and say 2 log 10 of 5 over 2 times 4. Okay, and the reason why you can do that is because you're taking 2 as a common factor. So the 2 is taken out as a common factor, and then you focus on log 10 of 5 on 2 plus log 10 of 4 using rule number 1. We know that you can multiply them together, so that cancels out to be 2. And so this now gives you 2 log base 10 of 10. And yes, you must know this one. So it's all about interpretation. This means 10 to the power of what will equal to 10? So if you read it that way, it makes it easier to solve. 10 to the power of what will equal to 10 is what this is saying. What should it equal to? 1. 10 to the power of 1 is 10. Okay, so that's why you don't need to know rule number 5, and you can say this is equal to 1, so the final answer is 2. Okay, so I do want you to read what the logs mean. So most students looking at the log, they're not reading what it's asking. It's just asking what's the power for the base 10 to get to 10. Because remember, log is the inverse. It's to find the power, whilst exponentials is to find the result. Okay, that's the difference between the two. So it's 10 to the power of what will give you the result of 10. That's why we know it's 1. Yep.
If it's 1, then why is the answer 2?
Because there's a 2 in front. So notice here there's 2 times. Notice the 2 at the front means 2 times. And we know that log base 10 of 10 is 1. Then 2 times the 1 must then equal to 2. Okay? Very good. So that's an example of how to do a logarithmic problem where I'm only using 3 rules. Okay, I'm only focusing on 3 rules. Rule number 1, rule number 2, and then rule number 3. Let's do another one. Let's try one with a couple of fractions here. Let's try 5f. Let's do 5f together. 5f, we've got log base 10 of x is equal to half times log base 10, 36, minus 2 log base 10 of 3. Okay, after a while, I am going to show you just one more key thing so that you can then do exercise 13F, how it relates to the idea, why do we need to know how to do logs. But let's try this one first. Okay, so here we go. Copy that question down. If you've done it already, fantastic. If you haven't, have a go with this. Okay, so I want you to use rule number 1, rule number 2, rule number 3. You should be able to do this in, say, I reckon 2 minutes. It's 10:38 right now. Let's give you 2 minutes to see if you can solve for x. You want to find what x is. Let's go. 3 rules, 3 simple logarithmic rules. Can you solve this problem? Let's go. 2 minutes. Two thirds. Let me see. 6 over 9 is 2/3. Oh yeah, it is 2. Well done, Ollie. I'm going to use rule number 3. So for me, this is how I would have done it. Rule number 3. Bring the value at the front or the coefficient to the power. So that now changes the problem to log base 10 of 36 to the power of half. For those who don't know what power of half is, it means the square root. Okay, so it's really saying square root of 36 there. Minus, again, this is log base 10 of 3 squared. So if you write that out correctly, log 10 of the root of 36 minus log 10 of 9. And we know that square root of 36 is 6. And 3 squared is 9. So remember, using rule number 2, we can combine the logs and it becomes 6 over 9, which is where Ollie was saying that is 2/3. So log 10 of 2/3. Don't forget, on the left-hand side, you still have log 10 of x, log 10 of x. I like to be clear in my notation, so I'm going to write log 10 of x all the way, okay? So here we go. Now, there are 2 ways to explain why the answer is 2/3. I want you to explain me both ways. How do we show from this step? Because though this step looks very simple, we're almost there, I find that the students don't actually know how to solve this part in the exam or the SAT. So it tells me that you don't fully understand what the next step is required. So there are 2 ways to show that x will equal to 2/3. Explain me one of the ways. How would you prove to me, or tell me, or explain to me, or reason to me that x equals 2/3? What's the first one? Very good. So remember with balancing the equation, if it's times 2, the opposite of times 2 is divide 2. Well, in this case, you have to treat it exactly the same thing. We want x. So I want to get rid of, I'm just going to choose a different color. I want to get rid of log 10. That's what I'm trying to get rid of. Just like saying times 2, mine is log 10. So the opposite of times was divide. Then the opposite of log was exponential, meaning you need to do the power with a base 10, because that's the units. That's how much I'm getting rid of it. So to do the opposite of log, I am now going to say, I'm going to do base 10 to the power of whatever the left-hand side is, and I'm going to do base 10 to the power of whatever the right-hand side is. So here we go. I'm balancing the equation. I'm going to do 10 to the power of this, and I'm going to do 10 to the power of this. Okay, because I'm balancing the equation. Whatever you do to it, I'm just doing an exponential. So here we go. 10 to the power of log 10 of x. So I've done that to my left. Then I do 10 to the power of log 10 of 2/3. See, I'm balancing the equation. And we know 10 to the power of log 10 are inverses of one another. Just like times 2 and divide 2 are inverses of one another, you'd cancel them out. Or add 2 and then subtract 2, they cancel out. Just like base 10 to the power of log base 10 are going to cancel out as well. This is what students find tricky to understand. See, if you can do 2x equals 10 and you'd say, oh yeah, divide both sides by 2, I'm doing exactly the same thing. It just looks different. That's the only thing that looks different. Okay, here you would have said 2 divided by 2 cancels out. Then why can't I say 10 to the power of log base 10 cancels each other out too? It's an inverse. So they should cancel out. These two cancel out. And so what are you left with? X equals 2/3. Very good. This is one way to prove it. What's another way to say that x has to be 2/3? What's another way?
Just use logic. Since they both like log 10, so you can just go x.
Very good. This is called solving by comparison. Since both left-hand side and right-hand side are equal, you can see here this is log base 10, that's also log base 10. So that means both brackets have to be equivalent in value if both equations are the same. So by comparison, I can then say, therefore, x equals 2/3. Okay, there are two ways to do it, and those are the two skills that you may need to sort of observe, because in year 12, it will not look as easy as this, but it follows the same principles. There'll be two ways to solve it. Okay, Andre?
We just mark it and then there's no last step.
As in if you just went right here?
Would you use the method mark if you didn't write the method mark?
Oh, so if you just went from here to here?
Yeah.
No, it'll be fine. This is almost assuming this is why when students look at solutions, they don't see this step. I show you guys that step. I show it to you so that you understand why that process works. And that's where it differentiates the students who find logarithmic hard, which shouldn't be, but it is. That's why it's always on the exams. That's what I think the students are missing. I feel like students they don't understand that it's just an inverse operation. That's all it is. If you can do opposite of times and divide, why can't you do opposite of exponential log? It's the same thing. It just looks different. And the looking different is the problem. The fact that you guys don't see this step often enough and you don't write it enough, that's the problem. So with my training, I try to make sure that you guys do that step each time so that you get better at understanding what you're doing there. Okay? But yeah, so normally they are going to assume that this is, once you get up to this step and then you write that, that's fine. They're not going to penalize you for that. Okay? All right. Very good. Now, that is exercise 13E. That practices law number 1, law number 2, law number 3. What you will find as you go through the exercise in chapter 13, the next one after you know your algebra is to sketch. But before we do that, notice in 13F, the topic says using logarithms to solve your problems. Each and every one of these problems here deals with logarithms. How do you know? The pattern is, if they give you an exponential problem and you need to solve for x, you use logs. If it's the other way around, if it's a logarithmic problem and you want to solve for it, then it becomes an exponential problem. Okay, so it's the reverse. So notice here, we ended up doing an exponential